Hello friends, today we'll start with analysis of tension members for welded connections. So note down the example. Determine the tensile strength of the tie member. Tie member is truss member of tie member 2 ISA 80 by 80 by 8. So there are two angle sections, Indian standard angle, connected to gusset plate on either side. Either side means both the sides, using 6 mm fillet weld of length 175 mm. One length is 100 mm, another length is 75 mm. So let this be the gusset plate. These are the two angles connected on each of the sides. If I take a longitudinal view, it will look like this. So this is a tensile force, angle 100 mm weld, 75 mm weld. So for this I have to find what is the tensile strength of the member. So first strength is yield strength of the angles. So from steel table, area of one angle of 80 by 80 by 8, it is given as 1221. Now for two angles, I have the area 1221 into 2, 2442 mm square. Now substitute the values, get the value of TDG. TDG is equal to AG into FI. AG is 2442, FI is 250, gamma m naught 1.1. So you have the answer 555 kilonewtons. Second, rupture strength. For rupture strength, refer to clause 6.3.3 for welded connections, page 33. So first go through the steel tables. Now here, so this is 6.3.3. Here we have for single angles, this is for bolted connection, this is for bolted connection, this is for welded connections. So this is a connected leg, outstanding leg. So all the distance of outstanding leg is taken as W, and BS shear leg is W. Why we are taking it as W? Because this leg, it is fixed here, it is fixed here. So this much length is in tension and this much leg is in shear. So BS is equal to W. So before we start, what you do is first write the equations for beta and TDN so that you understand what are the terms to be calculated. Okay. So here there are two angles. So what we do is, our logic is, we find the rupture strength of one angle and multiply by 2 at the end. Find rupture strength of one angle and multiply by 2. So I will draw another detailed diagram showing all the values. So this is a diagram showing these things. Gusset plate angles. So here weld is provided on both the sides, here as well as here. Similarly, show that welded portion here. Let this welded portion be L1, this be L2. So L2 is 100, L1 is 80. Now always longer leg should be connected. Here both the legs are same, so keep both as same. So this is unconnected leg, so unconnected leg, sorry, this is connected leg, so connected leg I am taking as A, 80. This is unconnected leg, B is equal to 80. So here this is connected leg, this is outstanding leg, outstanding leg. Now this black, it indicates gusset plate. Now this dimension, connected leg dimension is 80. Now we'll start with the analysis. So before we start with the analysis, always write the equations so that you will understand what are the terms to be calculated. So here if you look TDN, I have to find ANC, beta and AGO, and to calculate beta, this is the equation. So first write this equation, then write this equation. You will understand what are the terms to be calculated. So just copy the equations. I have the equation beta is equal to 1.4 minus 0.076 W by T Fy by Fu Bs by Lc, and this should be less than or equal to Fu by gamma m naught divided by Fy by gamma ml, and this should be greater than or equal to 0.7. So here what are the terms required? I require W, T already I know, I require Bs and Lc. Also write the equation for TDN. So this is the equation for TDN. Copy this equation as it is. So TDN is equal to, so TDN equation is 0.9 ANC Fu by gamma ml plus beta AGO Fy by gamma m naught. So here I need to calculate AGO and ANC. So we'll start with those terms first. First let us write the values of Fy. Fy is 250, Fu is 410 MPa, thickness T of the angle 8 mm. Now here first Bs. Now look at this diagram. What it says, Bs is equal to W, and W is nothing but outstanding leg. So write that value. So Bs is equal to W is equal to outstanding leg is equal to 80 mm. Next Lc. What is the definition of Lc? Just look here. For weld at both these sides, here it gives the equation, or length of weld along the direction, average length of weld. For bolted connection, I have to calculate Lc, center to center between the two bolts. For welded connections, it is average of both the welds. So here Lc is equal to average of both, means average of 80 and 100. Sorry, it is not 80, it is 75. 75 and 100. 100 plus 75 divided by 2. I have the answer 87.5. Now substitute all the values, get the value of beta. Before that, let us calculate ANC. What is ANC? ANC is net area in the connected leg. A, N indicates net, C indicates connected leg. Net area of connected leg. Even these definitions, they are given here. ANC, net area of connected leg. AGO, gross area of outstanding leg. So here first let us calculate ANC. Connected leg is this one, A. I have to calculate along this center dotted line. So my length is till here, so minus T by 2. So this is equal to A minus T by 2 into T. So A is 80 minus T is 8 by 2 into 8. So I have the answer 608 mm square. Next AGO, gross area. Gross area of, just look here, A is area, G indicates gross, O indicates outstanding. Gross area of outstanding leg. So here outstanding leg is B. This is B. B minus T by 2 into T. B minus T by 2 into T. So 80 minus 8 by 2 into 8 is equal to 608 mm square. Now substitute the values, get the value of beta. Now I have the equation beta is equal to 1.4 minus 0.076 into W by T. So W is outstanding leg, AT by thickness 80, Fy by Fu. So Fy is 250, Fu is 410 into BS by LC. BS is 80, LC is 87.5. This should be greater than or equal to Fu into gamma mW. Fu is 410, gamma mW is 1.1 divided by 250 into 1.25, and this should be less than or equal to 0.7. Now solve this. You have the answer 0.97. This should be less than 1.44, greater than 0.7. Hence beta is equal to 0.97 is the correct answer. Now substitute the values and get the value of TDN. So TDN is given by, so TDN is 0.9 into ANC. So 0.9 into ANC, net area of connected leg 608 into Fu 410 divided by gamma ml 1.25 plus beta is 0.97 already calculated into AGO 608 into Fy 250 divided by gamma m naught 1.1. So you, and always remember, multiply this value by 2 because there are two angles. So you have the angle answer 313 into 2. So TDN is equal to 627 kilonewtons. You have to multiply it by 2 here because there are two angles, and whatever this equation is there, this equation is for one angle, multiply by 2 to get two angles values. So this is 313.5. Now we'll start with third step, block strength, block shear strength. Now refer to 6.3, 6.4, 6.4 clause, page 33. For that, let us put a small diagram. Now to find block shear strength, I require LC and LT. LC is average of these two, already I found, and this value is LT. LT is equal to 80. Now before we start, directly write the equation so that you will understand what are the terms to be calculated. Now TDB equation, or just copy the equations from here. AVG into Fy by root 3 gamma m naught is equal to AVG. So these two are the equations for TDB. Now if you look at here, I require this AVG, ATN, AVN and ATG. So I need to calculate these four values. Now I will calculate these things. AVG first. What is AVG? Here V indicates shear, shear means parallel, G indicates gross. So I will write value parallel to load. So here parallel to load is LV, this value. Or I can calculate those values first. So first let me write LV. What is LV? Average weld length parallel to load, and that is 100 plus 75 divided by 2, 87.5. LT in tension 80 mm. Now here AVG, gross length parallel to load. So parallel is LV into T. So I have the answer 87.5 into 8, 700 mm square. ATG. So ATG is nothing but LT into T. T is tension, G is gross. 80.8 into 8. Sorry, 80 into 8. So I have the answer 640 mm square. Now remember, in welded connections there are no holes. So AVG is equal to AVN. Both are same, is equal to 700, and ATG is same as ATN. Net and gross are same since there are no holes. This is 640. Now substitute the values, get the answer. So TDB1 is AVG into FY 250 divided by 1.1 into root 3 plus 0.9 ATN 640 into FU is 410 divided by 1.25, and again you have to multiply this value by 2 because there are two angles. Whatever these equations are there, these equations are for one angle. There are two angles, so multiply by 2. So I have the answer 561.5 kilonewtons. Similarly, second equation I have 0.9 AVN 700 into FU 410 divided by 1.25 into root 3 plus ATG 640 into FI 250 divided by 1.1 multiply by 2, 529.5 kilonewtons. So I have the two values here. Now tensile strength is least of above, and I have the answer 529.5 kilonewtons. So this is the tensile strength of the double angles connected by weld. This completes the problem. Thank you.